Welcome to the Mars Society Convention. I would like to introduce you to our guest speaker today, Miguel Cooper. He is a freelance writer and IT specialist, and he has been a space enthusiast since 1968. He will be speaking to us on the first human on Mars. Welcome, Miguel, and go take it away.
Thank you. Before I begin, I would like to take a few seconds to express my recognition to the Mars Society for doing this amazing effort in these difficult times to continue building the path that hopefully will take humans to Mars a few years from now. We all share the vision of Dr. Subrin. My sincere thanks to all the organizers, volunteers, and to James Pork and the IT team for implementing this solution, making this convention a global event. Now, let's go to Mars. This presentation is based on my own concept of how I consider the first human mission to Mars could be. The project is an international effort that initiates in 2020, aiming to reach Mars in late 2031 for a landing the same year or early 2032, depending on technical and meteorological factors. This mission should be the beginning of the exploration of Mars that eventually will become the departing point for future endeavors. Please notice the small square in the right side of the slide. It shows the year each event takes place. Below, it's a small rectangle indicating that the crew training is ongoing. The World Space Exploration Organization. This is an organization that will manage global space programs that will bring benefits to Earth by unifying efforts to reach common goals. This organization is a coordination. It has a chairman or director selected every 4 years. The executive board will be formed by the heads of space agencies, directors of universities, directors of space industry companies. The main objectives of the organization are shown here. When thinking about how a human space mission to Mars could take place and what is needed, I took in consideration these factors: strategy and architecture, deep space exploration vehicle, Mars surface station, supplies for Mars orbit and Mars surface, crew protection from radiation and sandstorms, Mars communications and mission control. The human factor is the most critical one for each space mission, but in this case, the crew will face situations never experienced before. The crew must be trained in a group since the beginning. Any difference between them should be detected, as the mission will go from April 2031 to November 2033 approximately. Virtual technology must be implemented and used for personal messages with their families and events as religious ceremonies, and for continued training during the mission. Physical exercises for the crew for all the journey is a must. Medical exams must be performed and analyzed on board by an equipment and results sent to Earth for follow-up. Special attention is needed with the crew due to the fact that comparing with all human space missions, they will not be able to see planet Earth, and this may cause a sensation of loneliness. Adding to this the fact that there will be a delay in communication between the crew and Earth. Therefore, as mentioned, constant virtual reality communication will be a critical factor. This slide presents some additional considerations for the mission. For instance, which will be the best plants to be harvested on Mars? Those that require less water and have high nutritional value and help to generate oxygen. I consider that besides biologists, natives from each region could contribute with their knowledge of plants and their nutritional and medical values. Horizontal and vertical crops will be included. The crew must learn to perform certain medical procedures and should have access to video library for complex issues. The time measure on Mars must be defined by the crew. Solid waste processing system. oxygen generation and recycler, and water processing system must be included. One critical issue is the mission controller. Again, with difference to previous experience, MCC will not be able to control and to receive telemetry in real time as in previous missions. Mission control must learn a new way to work. There, they will have to decide until which point their direct control is effective, depending on the signal delay. After that point, the crew will their own mission control with these definitions. Critical issues must be solved by the crew and informed to MCC, which will respond with a recommendation of the solution applied. Non-critical issues can be responded by MCC, as well as updates and recommendations. The following slides will explain the concept I am considering. For the Mars surface station, the three main components will be delivered by Mars rockets, using the techniques showed by SpaceX and Blue Origin. The rocket will be launched from Earth as a cargo in a heavy lift rocket that will place its upper stage and the container with the landing rocket on Earth orbit, from where it will begin its journey to Mars. Precise landing is required because all these rockets should land in a predefined area that will be an imaginary circle in which the central point is where the Mars lander will arrive. This slide shows the concept as a test of a landing rocket, just a parabolic flight to verify the procedure. The crew will need a deep space exploration vehicle. For this concept, the Orion and its extended service module will be used. This particular slide shows the test mission for the Orion and the SLS, a mission to orbit the Moon. The previous slide just showed the vehicle that the crew will use for the journey, but additional equipment is needed for this long journey and for Mars landing. In difference with the Apollo program, the additional equipment will not be carried to orbit in the same rocket. This is because of weight issues. Instead, it will be sent to LEO. One option was to use it, One option was to send it to the ESS for final preparation and delivery. I thought that a better option is to build a small orbital space station that I call Air Orbit Service Station, that will have one central module similar to Columbus, one airlock module with 4 docking ports, and one service module for the Mars lander. It will have an structure that can be extended all the way to service a space vehicle, just like a rotation structure on a launch pad. These components will be launched to LEO by different vehicles, and LEO crews will assemble them and make them operational. Few years ahead, the habitat, its extension, and the Mars lander will be received to be prepared for the mission. There is another component, the PDCU, for portable docking and capture module. This component will be docked to a LEO crew vehicle and has an RMS to capture and deliver objects in orbit. The other side of the PDCU will be docked to one of the ports of the EOSS. As it was said, the crew will be training in simulators and in areas that resemble Mars, like deserts, and will go to Antarctica. They will practice in the neutral buoyancy lab. For this experience, I added a component, a module that will be added to the ISS and will have a rotation to simulate gravity of Mars. This will let the crew experience the whole journey. Microgravity in the ISS, Mars gravity in the Schiaparelli module. This will let mission control test procedures and experience a simulated delay in the signal from Earth to Mars and back. The mission strategy is as follows. The Mars components will be sent to Earth orbit. A LEO crew will deliver them to the Mars crew on Earth orbit. When returning from Mars, the Mars components will be undocked from the Orion and will be captured a few weeks later by a LEO crew. This process is detailed few slides ahead. This slide shows the second Orion mission to orbit the Moon, this time testing the complex delivery and release operations of the Mars mission strategy. The year is 2025. The landing rockets have been tested on Earth. The next step is to test them near the Moon. This slide shows the test of launching a rocket that should reach the Moon orbit and perhaps land on the Moon. The next test is to deliver a rover to the Moon's surface. This is the same technique that will be used to deliver the Mars cap components to the surface of Mars. The key elements here are an accurate landing and the operation of the cargo ramp. We are in the year 2027, just 4 years away for the human mission. All this time, the primary and backup crews have been training. For some years, a Mars sample return mission has been planned. Well, there is a possibility to have a mission with two objectives. First, the Mars sample return mission, and second, test the Mars lander on Mars and the whole journey. The idea here is to send a Mars rover inside a Mars lander with the necessary hardware to lower the rover to the Mars surface and be able to retrieve the sample container later to store it in the lander. The rover will stay on Mars to perform additional exploration, and the Mars lander will dock to the Mars orbit with the return vehicle and will arrive to lunar orbit, where it will stay until it is considered safe for a crew to retrieve the samples. As a vehicle will remain in Mars orbit and other will land, one important issue is the continuous communication between them. The orbital team will be the MCC of the mission. They will contact Mission Control Earth for updates and recommendations. From orbit, the crew will monitor the excursions on the surface and will warn them if there is a possibility of a dust storm forming in any place. Shown here are 3 communication satellites positioned in a Mars synchronous orbit 120 degrees apart. Also, if it is decided to send a first model of an international Mars orbit station, could help with this communication requirement. By 2028, the Mars surface station or Mars camps components should be launched to allow them to arrive to Mars before the crew leaves Earth. As was mentioned before, each component will be sent in individual Mars landing rocket. Each one will be sent to Earth by a heavy lift rocket, and from there towards Mars by firing the engine of the upper stage of the rocket. It can be a stack configuration or any other configuration that may be tested in the following years as the distributed launch system configuration. This slide shows the Mars lab being prepared for launch. Early 2029, the 2 additional components of the Mars camp must be launched to reach Mars in the following year, following the same strategy. One of the rockets will have the capability to launch from Mars to test this functionality that could be used to send some material to orbit or a crew member to reach the habitat, Orion, or the Mars orbital base. All the Mars rockets should have landed in the specified area, so astronauts will be able to reach them when they arrive. By 2030, the Mars lander habitat, its extension, should be docked to the EOSS, where crews will run tests on them. Load supplies delivered to the EOSS by cargo vehicles, update hardware, and software. Late 2030, the Mars lander will be positioned in the docking port of the habitat extension. Tests will be executed to be sure that there are no leaks and all systems are ready to go. The final configuration to be delivered is ready. The Orion will dock to the docking port of the habitat. The journey is about to begin. Astronauts on Earth have been in quarantine for 2 weeks. They are ready to board the Orion. This time, a portable white room will be used to avoid any contamination. The LEO crew aboard the EOSS will prepare to board the LEO vehicle, to dock the EOSS, and align with the habitat to grapple it with a PDCU RMS. At certain point during the SLS Orion countdown, perhaps during a hold, the LEO vehicle will undock from the EOSS. As it is docked to the PDCU, we'll move towards the habitat to grapple it with the PDCU RMS. Once it is secure and all verifications are done to undock it, the habitat will be released from the docking port of the EOSS and move it backwards. At this point, the LEO crew will notify the launch control. Computers of the LEO vehicle and Orion will be linked to calculate the rendezvous point as the countdown reaches 0. For the first time, a launch countdown will include activities from a vehicle on orbit. Also, we'll have to respond go or no go at the polling time. The SLS Orion will be launched, and the LEO vehicle with the Mars components will begin its journey to the rendezvous point, calculated by the synchronized computers of Orion and LEO vehicle. Once the approach phase is terminated, Orion, with the last SLS stage, will act as the static docking element. The LEO vehicle will maneuver to align the docking port of the habitat with the docking port of the Orion using the RMS of the PDCU. Once the objectives are aligned, the habitat will be moved towards the Orion until contact is done to begin the secure docking procedure. When mission control confirms the habitat is secure, all logs confirm and that there are no leaks, the RMS of the PDCU will release the hooks to begin retraction. Once this is done, the LEO vehicle will fire its navigation thrusters to begin movement away from the Orion, and after leaving the imaginary safe area of the Orion, the LEO vehicle will synchronize its computer with the EOSS to begin the journey back to it. The Orion crew will perform verifications and will prepare for firing the SLS stage rocket to begin the journey towards Mars. When the firing is complete, the Orion with the service module, the habitat, and the Mars lander will undock from the rocket stage and will fire its engine to gain distance from the stage. During the first hours of the trajectory, the crew will open the hatch of the habitat to begin its activation. They will continue training with virtual simulation, perform their physical training, and will receive virtual reality messages from their family, friends, and religious services. They will open the hatch between the habitat extension and the Mars lander and will begin to perform checklists and apply updates sent from Earth. By late December 2031, the vehicle formed by the Deep Space Exploration Crew vehicle and its service module, the habitat and its extension, and the Mars lander will reach the Mars orbit. Maneuvers must be done to be captured by Mars. Otherwise, an abort sequence must be executed to send the vehicle back to Earth without landing. As we don't want this to happen, we will assume that the vehicle enters on orbit. They will adjust it to achieve the circular orbit they need. Once there, they will begin to test the Mars lander and schedule a Mars landing date according to the orbit. Of course, before a decision is made, they need to be sure that no sandstorms are in progress and that it's safe to land. When the conditions for a landing is secure, at the designated orbital position, the Mars lander will undock from the habitat with 4 astronauts aboard and will proceed to descend to Mars. First, it will experience the atmospheric fire re-entry. Then, it will open the parachutes and will extend its engines and landing pads. The engines will fire to slow the vehicle. At any moment, the landing could be aborted. At touchdown, the engines will shut off, and the Mars lander will be configuring an emergency lift-off state, just in case they need to depart urgently. As the vehicle must land in a specific area to be in a short distance from the Mars rockets that contain the Mars camp components, during the descent phase, the lander will synchronize its computers with the ones of each rocket and the one aboard the habitat. This synchronization will send commands to the engines to guide it to the desired landing target. On the surface of Mars, the lander must being near the central point in reference to the rockets. The area is Christ Planitia. After the crew first steps on Mars and initial tasks and ceremonies, the first task of the crew will be to walk to the location where the Mars rocket with the Mars lab is, to unload it and transport it to the selected area near the Mars lander and begin its activation. This slide shows the methodology to unload it. The Mars rover and the greenhouse will unload in a similar way. It is important to know that the crane that is used to unload the Mars lab can be dismounted to be used later in the mission. The fully operational Mars camp will look like this. The Mars rover can be docked with the Mars lab. The inserts on top show a concept of the greenhouse. The orbital and land crews will continue their training for the milestones to come. From January 2032 to January 2033, the crew can perform these excursions. The trajectory is presented in the next 3 slides. The Mars drill is shown here. As requested by planetary scientists or by visual appearance appreciation by the crew, the drill will obtain samples of the structure beneath the surface up to 7 meters in depth. The drill can operate in an automatic mode.
Miguel, you have about 5 minutes.
Okay. Okay. For each excursion, the crew will visit various pre-selected areas. On each one, they will leave a remote station to keep monitoring temperature, wind speed, presence of dust in the atmosphere, humidity, and have a camera, an information storage unit, and a transmitter this will be operated by batteries charged by solar panels. Each station will have a unique ID. Next. The last excursion consists of arriving to a specific point to release a turbo-propelled drone to explore one of the Mars volcanoes as Ascarius Mons. Supplies will arrive to the habitat with vehicles that will arrive to the orbit of Mars with automatic docking procedures. For the surface of Mars, cargo vehicles will land following the sequence shown here. Once on the surface, it will open the cargo section to retrieve the container from it, using the Mars crane that arrived with the Mars lab. These containers, besides the cargo, will be used as extensions for the Mars camp, as storage areas or remote stations for future exploration. This is, a container can be taken to a specific area on a cargo platform pulled by the Mars rover. It can be activated with solar panels to support a crew few days on their way to explore farther places. Once the mission comes to an end, the crew will configure the Mars lab and the rover for hibernation. Only few systems will remain active for monitoring from Earth. The harvest of the greenhouse must be collected and the new plants must be planted for the new harvest. The greenhouse will continue working in an automatic mode, of course, monitored remotely from Earth. The protection covers for strong winds and sandstorms will be placed and secured. After this is done, the crew will proceed to board the Mars lander. Its computer will be synchronized with the one aboard the habitat to calculate the rendezvous maneuvers and docking operation.
1 minute, Miguel.
Okay. Before the firings of the service module engine to leave the Martian orbit, the crew will make sure that everything in the habitat of Mars lander is secure. We'll prepare the set of samples that will be carried with them to the selected container to take them to the Orion. Then we'll close the hatch of the Mars lander and the hatch to the habitat. At the program moment, the Mars engine of the service module will be fired to leave the Mars attraction. A second fire will make them leave the Martian attraction. During the journey, the crew will continue with their activities, exercise, and training. Next. At about 30,000 kilometers from Earth, the habitat Mars lander will be undocked from the Orion. the control of this will be taken by the European Space Mission Control. It will fire small thrusters to gain distance from the Orion that will continue the return to Earth. The Habitat Mars lander will continue to perform orbital adjustments for the following weeks until it reaches an orbit of about 400 kilometers to be captured by a LEO vehicle. The Orion will splash down in the Pacific Ocean, where it will be recovered and placed in quarantine. The Habitat Mars lander block is captured by a LEO crew with the RMS of the PDCU. This crew will take it to the EOSS, where it will be docked, and will keep closed until scientists consider it is safe to open. And perhaps the samples stored there will be sent to the ISS or to Earth. I hope this presentation has been interesting to you. Thank you for listening.
Thank you very much, Mr. Cooper, and we have time for a few questions.
Okay.
So the first one is, if there is a change in crew activities sequence of events that are needed to meet a specific scientific goal, do you consider it a critical or non-critical decision?
Well, I think everything in this mission is a critical decision, especially all the things that have to be related with the crew, because of the length of the journey and the conditions they are going to have. It is needed to take every aspect of this mission critical.
Okay, so the next question is, given your reliance on NASA to archive this plan, how do you intend to ensure funding, which given the size of this plan would be vast, would not be good through the 12 years, 3 presidential terms, and at least 1 change of administration?
Well, the idea in one of the first slides, the idea that I was presenting is the creation of one organization that is the Earth Exploration, Space Exploration Organization. And I think that is needed that this kind of organization, all space agencies invest in this project. One country perhaps will do the Habitat, the other country will do the Mars rover, the other one will work with the SLS and the Orion, the other one will work with other things. And this is a coordination. And what I was thinking that could be happening in an ideal situation is that as every country is going to contribute to this one, they will also have the benefit of creating new companies, new employees, new developments that in the end they can get money back from the invest they have done, because everything that is done to go to Mars is for the benefit of Earth. So everything that is done there will apply for something here on Earth.
Okay, thank you. And the last one is, close to 50% of everything we have sent to Mars has crash landed. Is this a factor when landing humans for the first time? And if we did lose a crew, would it set back a Mars return for 60 years?
Well, what I was thinking is the crew will get to near Mars and will slow the vehicle to be trapped by Mars orbit. In the case it cannot be done, because this cannot be achieved, the vehicle must have an abort plan to fire the engines and send back the vehicle back to Earth. Of course, this will make a trip for maybe two years to reach Earth, but this is the only thing that can secure that the crew will be safe all the way. In fact, all the supplies they have, they must be considered for this situation.
Okay, so thanks again, Mr. Cooper, and thanks you very much for your attention, and we will see you in the next talk. So thank you very much.
Thank you.
Bye-bye.
Bye.